Alright, so it's time for some Pythagorean Theorem review. Now this is a review from Algebra 1. You should have learned it in Algebra 1. Hopefully you retained it. If not, we're going to go over it right now. So, Pythagorean Theorem is used with a right triangle. Let me try and draw one in there. Sometimes this iPad setup gets a little laggy, if you will. Alright, so you might remember this bad boy. This is the Pythagorean Theorem. A squared plus b squared equals, you guessed it, c squared. Now, a and b, these are the legs. And then this guy right here, that's the hypotenuse. Okay? I don't have room to write that all the way out, but that's the hypotenuse. So this right here is our c. It's always across from the right angle. Right? And it's the longest of the sides. The legs, doesn't matter which one is which, A or B, it does not matter. This could be A, this could be B, or this could be B, and this could be A. However, the one across from the right angle is always C. Awesome. So we can use this to find missing lengths, given two of them. Sometimes we'll actually be given like angles and a side. That will come later when we deal with trigonometry. But for now, we got two lengths, we can find the third of a right triangle. Alrighty, so now we're going to apply our Pythagorean Theorem. As always, we're going to do as much application as we possibly can. Some pure math, but mostly application. So here we are stick building a roof. Now that can be a great way to make more space in an attic. It'll probably save you money if you're doing it yourself rather than purchasing pre-built rafters from somewhere like Menards or another lumber yard. But we're going to stick build this thing. Now, the building itself is 30 feet wide. It has 10-foot walls, so 10-foot ceiling, nice and tall, and it's a total of 18 feet tall. Now, I know that this one might look a little different than what we come out with, but we're going to go with those numbers, okay? So it's a total of 18 feet tall, which I would think would mean that, and if it's 10-foot walls, this right here, that's going to be 8 feet. How did I get that? 18 minus 10, total of 18 feet tall, and we got 10-foot walls. All right. So that length is 8. Now the whole building is 30 feet wide, so just half of it would be 15. Now you might see what we've got here. We have ourselves a right triangle. Now because of the way the picture's been taken, it kind of looks out of whack, but that's okay. We've got our numbers down. This is where the math helps. It says, how long should the rafters be cut? Well, the rafters in this case are the hypotenuse, the guy across on the right angle. This is our rafter right here, okay? That's our rafter. So how long does it need to be cut? Now you see here in this picture there is a bit of an overhang that allows for your fascia board and your soffit as well, if that's what you're doing. That's pretty normal, especially for these gable end houses like we have here. That length can change depending on what you're planning to do. Maybe you want a 1-foot soffit or you want a 2-foot soffit, who knows. But what we're going to do is we're going to find just the basic rafter cut, and we can always add in that overhang later on. Okay. So let's figure this out here. We got an 8 and a 15. Well, we could use a Pythagorean Theorem. 8 squared plus 15 squared is going to equal our c squared, because I'm looking for my hypotenuse. If I knew my rafter and I knew the height of my building, I could find the width. Using Pythagorean Theorem, it'd just be a slightly different problem. Okay, well, 8 squared plus 15 squared. Those are some big numbers. I'm going to have 64. Oops. My goodness, this thing. Sometimes it jumps around on me. All right. 64 plus 225 equals c squared. All right, so far so good. Now, what do we do next? Well, we got to add those together to get 289 and square root it. And if I square root that, I'm going to get 17. This is actually one of our triples, one of our families. It's an 8, 15, 17. We've got a few of those. I will bring that up at the end of this video. Or actually, let's do it right now. So we've got our 3, 4, 5. That's a common one. We've got our 8, 15, 17. We just dealt with that, right? Oh, I forgot one. 5, 12, 13. And then we've got our 7, 24, 25. You know those 4, super helpful, especially that 3, 4, 5. That's a common one to use, especially when checking for right angles. You can make a little right triangle as you're trying to make a right angle. All right, we'll do that in class. So I've got my my rafter here. Obviously, we're going to have to add a little bit on for that overhang, for that soffit and the fascia board, but overall, we've got a pretty good idea of how long that thing needs to be. So I'd say we'd probably get ourselves some 18-foot boards for our rafters when we go pick them up from the lumberyard. Alright, now we got P. Diddy framing up a space for a new concrete patio. He was at his buddy's house the other day. I believe Fetty Wap. He was hanging out over there and saw this dope concrete patio. He was like, you know what? I just got to have one. So he plans to have a 10 by 18 rectangle. He measures the sides and makes sure that, you know, those are all good. But he also measures the diagonals to confirm that he has 4 right angles. When we get into quadrilaterals, we'll talk about that as being a property of a rectangle, which also applies to squares. So this is often referred to as being square, making sure it's square. You'll use this when framing up doors. Really anything that you want right angles, you can measure the diagonal, diagonal to diagonal, and you'll be able to know that, hey, I got something that's square, okay? So I have 4 right angles. How long should these diagonals be? Well, if he's going to hold a tape measure, you know, from one diagonal to the next, what do we have here? Well, if you look at it, and I'll try and draw it in best I can, we got ourselves a right triangle. And if this thing is 18 by 10, woo, Pythag it up, you know what I'm saying? So P. Diddy's just going to, you know, take out some scratch paper and probably his TI-84, courtesy of his other buddy, T.I., the rapper. So we got 10 squared plus 18 squared equals c squared. So how long should the diagonal be? Well, let's solve for it. So if I do 10 squared plus 18 squared, right, we're going to get 424 equals c squared. Now let's go ahead and square root that in our calculator, and we're going to get c equals approximately, you know, I'm going to make that approximate for my equals sign, make it a little squiggly, because that means we've rounded. And it says 20.59. So 20 point, we'll say about 6, okay, around to the nearest 10. So just over 20.5 inches. So if he's looking at his, you know, he's taking out his tape measure, he's got a buddy holding it on one end, making sure it's pulled tight, and he gets about 20.5 inches right around there. He should get that for his other diagonal as well, and he knows it's all good. Okay, now there's something else we need to do. When we're drawing these square roots, that's always helpful. Right, we square rooted it to get that 20.6. In our class, we're pretty much be using decimals, but there are times where on like a standardized test or you know, in a future class, you might be asked to simplify that radical. Now, this is a big number here, but we can handle it, okay? So if I have the square root of 424, I can break that down with a factor tree. Now, there's a couple methods here. You can divide by, like, say, 2 until you can't divide by 2 anymore, and then continue on with 3 and 5, all your prime numbers. Or, my preferred method is dividing by perfect squares, meaning numbers that square root nicely. So some of my perfect squares would be 4, 9, 16, 25, 36, 49, 64, let's see here, 81, 100. Okay, let's start with that. And you know, one more. How about 121? Okay. So those are my perfect squares. Is 424 divisible by some of those? Well, let's see. If I do 424 divided by 4, I get 106. 106, that seems like maybe it could be divided by something else as well. So let me try 424 divided by something bigger. How about, let's stay even, let's go with 16. Ooh, that's 26.5. That's no bueno. Well, how about 424 divided by 36? 11.7 repeating. Well, maybe it's not. I don't know. Maybe we can only divide it by 4. Let's try 49. Nope, still a decimal. So I'm willing to bet 424 divided by 4, which is 106. So let's see here, 4 and 106. Alrighty, can we divide 106 by, let's see here, by 2? That gives me 53. I think we're prime with that. Okay. So I got 4 and 106. Well, what's the square root of 4? That would be 2. And I couldn't square root 106, so 106 stays. Okay? Boom. That would be an exact answer in simplified radical form. In our class, decimals usually our best bet, just because I don't know what 2 root 106 is on a tape measure, but I know where 20.6 is roughly. Right? That's more useful with the decimal. But knowing how to prime factor tree it and simplify it is a useful skill as well. I'm going to do like 1 more or 2 more of those simplifying radical problems, just in case you didn't quite grasp it with that big number, something a little bit easier on the next page. Alright, let's try these two. These are a little more manageable than the last one. That was a bit of a bear, if you will. So we're going to do some factor tree action. Now, for square root of 18, I can do, let's see here, 18 is divisible by 9, which is a perfect square, and that would leave me with 2. Well, what's the square root of 9? 3, and the 2 stays in. Cool. So how about with 40? Well, I could divide that by 4, which will leave me with 10. 10's only 2 and 5, so I can't get any other perfect squares out of that. So what's the square root of 4? That's 2. Square root 10. Cool. Not too bad, right? Now, there are other ways of doing this. I'm going to make this a little smaller, and we're going to try it in a slightly different way that you may have seen before in Algebra 1, depending on your teacher. So if I have square root of 18, I will actually change colors here. Square root of 18, I could do, a lot of people will do like, okay, well, let's see here, we got 2, or maybe they'll do numbers that are close to each other, like 6 and 3, and then they do 2 and 3, and you find yourself a couple pairs. So that means that 3 comes out and the 2 stays in, because the 2 didn't have a pair to come out. Same answer, just a different way of going about it. Same would apply for square root of 40. A lot of times people will pick 2 numbers that are very close together. You know, there's multiple ways to start this one. Well, let's say we got 5 and 8. This would be 2 and 4, 2 and 2. Oh, got a pair. And what I'm left with, so I got 2 square root, because the pair of 2's came out. I'm left with the 5 and the 2 multiplied together, which gives me 10. All right, same answer as before, just a slightly different approach. America. All right, now President Obama's deciding to get into the HGTV game. He's starting his own home reno show, and he has some free time after being president. So he's framing up a roof and figuring out the bird's mouth cut, and the pitch of the roof is 312, which means that it has about a 14-degree incline, something that you could see on your Swanson Speed Square or your roof framing square, you know, any one of those. So, and we can actually figure that out using inverse trig, which is coming, don't you worry. Alright, so the bird's mouth, we're talking about this area right here, okay? So this cut particularly. You got your heel cut and your seat cut. Alright, so the roof pitch is 14 degrees, so it's going up at 14-degree angle. What are the measures of the angles in the bird's mouth cut? Well, if you notice here, I'm going to do this in red, we've got ourselves a little triangle. I'm going to make that bigger. Okay, so we got a right angle. So one of them is actually going to be the 14. I'll toss that in there. And then what would the other one be? Well, what do we know about all the angles in a triangle? All of them should add up to 180 degrees. So if we got 14 for one, we can either do it mentally or pull out our handy-dandy calculator. I bet you guys are going to start doing these things without calculators, because it's going to be kind of a pain in the butt to have a calculator when you're on top of a roof, right? So this guy becomes 76. Whoa. This thing is a little laggy on me. So this angle is going to be 76 degrees. There we go. We got our 2 angles, 14 degrees whoop, and 76 degrees. So you can set your framing square there, your rafter square, to that 76-degree mark. I think we're going to be going over that more in class on the construction side of things. But that's how it ties in with math. You've got 180 degrees in the triangle. If you know one of them, and it's a right triangle, you can get the other one, right? You can get all 3 angles. dope. We'll be talking about rafters and bird's mouth all the time because there's tons of math in it, especially when we get to quadrilaterals and parallelograms. Woo-hoo-hoo-hoo-wee. America.